anytime you start a new problem, I encourage you to open up a new script file, clear your workspace so that it's empty, and CLC your command window. So you're starting with a blank slate. Then you can guarantee that you're not going to have variables that are named the same that are interfering with each other. Okay, so open up a new script file, open up a new file, really, script or function. Clear your workspace, clear your command window. Okay, so number 5, write a function n primes equals count primes n. So function np equals count primes n. Okay, function, start, save my file. Okay, I've got something. Now I'm going to see what it does. Takes in an input integer n and returns an integer n primes, which is the number of primes between 2 and n. So essentially, I am going to iterate through n numbers, so 2 to n. Iterate from 2 to n. And here is where it says you must use a while loop with a nested if branch. So we're forcing you to use a specific thing. So I need while, and I need end. I need a loop control variable. I need some number. I equals 2. What is my starting number? I equals 2. When do I want to end? I want to end when I is equal to n. When I is equal to n. So to invert that, I'm going to continue while I is less than or equal to n. And then how am I going to modify it? I equals I plus 1. So here's my 3 components for my loop control variable. I starts at 2. I is going to continue as long as I is less than or equal to n. Then I increments by 1. This would look the same as a for loop for I equals 1 or 2 to n. This would do the same thing. This is the for loop version. This is the while loop version. Inside of my while loop, it says you may use the is prime built-in function for a branch statement. So if my number is prime I. So if I go down to MATLAB, I can look to see what is prime does. It's going to be 1 or true if the element, if I, is prime, 0 otherwise. So if is prime equals 1, then I'm going to go ahead and count. Okay, so I am counting how many values there are. When you count, you are essentially summing. So my count starts out at 0, and I am counting by 1 inside of my loop. So if is prime is equal to 1, count by 1. So let me go ahead and run it. So n equals count primes, I don't know, start with 10. Okay, output argument, np and others may not be assigned. I don't have anywhere that says np equals. np is my count. So I'm just going to go ahead and change my variable. Save that. Count primes. So n equals 4. If I look at the numbers between 1 to 10, 2 is prime, 3 is prime, 5 is prime, 7 is prime. So that's 4. So that's great. So let's keep going. Let's test it again. 100. N is 25. Sure. We'll just trust it. Okay, this is one of the ways to do it. This is how you were told to do it. There are other ways to do this problem. We could use a for loop. We could use a for loop instead. Same idea, but we don't have that loop control variable. We just have our loop index variable. So np would still start out at 0. We'd still have our if statement. If is prime I equals 1. np equals np plus 1. We would still have this. We just wouldn't have our loop control variable because we'd have a loop index variable that automatically changes value for us. We could also do this without loops. We could say that our I values are going to be 2 to n. And then I could say np equals the sum of all the values of where I is prime. So let's say n equals 20. So I would be 2 to 20. Is prime is going to return a logical array where there's a 1 wherever it's prime. If I sum all of that together, it adds up all of those ones. So there's a total of 8. So this is another way to do this problem. So unless you are told a specific way, choose whichever one you want to do. It doesn't matter. If you are told a specific way to do that, like we were told here, make sure you're using that method.